April 18, 1942. The morning sun broke over the Nakajima Aircraft Company's sprawling factory complex in Oda, north of Tokyo. Inside the cavernous assembly hall, the air hung thick with the smell of riveted aluminum and machine oil. Hundreds of workers moved in synchronized precision beneath the skeletal frames of A-6M fighters suspended from overhead cranes like steel dragonflies. The rhythmic hammering of metal against metal echoed through the space, a mechanical heartbeat that had sustained the Imperial Japanese Navy's dominance across the Pacific for 16 months. On this particular morning, the 5000 rolled off the production line, its polished fuselage gleaming under the factory lights. Engineers bowed to the aircraft as though it were a shrine. To them, it was more than a machine. It was a manifestation of Yamato Damashii, the spirit of Japan itself, forged in discipline, sacrifice, and unwavering devotion to the emperor. 6,000 miles to the east, in the sprawling industrial heartland of America, a different kind of morning was unfolding. At the Willow Run plant outside Detroit, Michigan, the largest factory building ever constructed under a single roof stretched nearly a mile in length. Here, the Ford Motor Company had converted its automobile assembly lines into an aviation production colossus. Every 63 minutes, a B-24 Liberator bomber, for engines, 10 crew, 8 tons of ordnance capacity, emerged complete from a final station. Workers clocked in for 8-hour shifts, collected union wages, and returned home to houses with refrigerators, radios, and running water. They did not bow to the bombers. They built them with the same practical efficiency they had once built Fords and Chevrolets, then went home for dinner. The contrast between these two worlds, one rooted in spiritual exaltation, the other in industrial pragmatism, would define the outcome of the Pacific War before a single additional shot was fired. The story of how Japan lost the Pacific War is often told through the battles, Midway, Guadalcanal, the Philippine Sea. But the true defeat was written not in blood and fire, but in steel tonnage and production schedules. It was a war decided in the factories, in the calculated arithmetic of industrial capacity, in the cold logic of assembly lines that never stopped. The Japanese Empire entered the conflict with the finest naval aviation force in the world, and the unshakable conviction that spirit could overcome material disparity. They were wrong. Not because their spirit was insufficient, but because they fundamentally misunderstood the nature of modern industrialized warfare. They built their Zero fighters as works of art, each one a testament to engineering excellence and national pride. America built its Mustangs and Liberators as products, stamped out with the indifferent efficiency of a nation that made everything from toasters to tractors in quantities that defied comprehension. When the Mitsubishi A-6M first appeared in Chinese skies in the summer of 1940, it represented a revolution in fighter design. Engineers had achieved what Western aviation experts deemed impossible, a long-range fighter with extraordinary maneuverability. The Zero could outclimb, outturn, and outrange any fighter aircraft in the world. Its maximum range exceeded 1,900 miles with drop tanks, more than double that of contemporary American fighters. In the hands of Japan's elite naval aviators, men who had trained for years in the rigorous disciplines of aerial combat, the Zero seemed invincible. During the first 6 months of the Pacific War, Zero pilots achieved kill ratios that approached 10 to 1 against Allied aircraft. They swept the skies over Pearl Harbor, the Philippines, the Dutch East Indies, and Burma with a dominance that bordered on the mythological. But the Zero's supremacy came at a price that would prove fatal. To achieve its remarkable range and agility, Mitsubishi's designers had stripped away everything deemed non-essential. The Zero carried no armor plating to protect its pilot. Its fuel tanks were not self-sealing. It possessed no bulletproof windscreen. The airframe was built to minimum tolerances, sacrificing structural strength for reduced weight. A single burst from a .50 caliber machine gun could transform a Zero into a fireball. Japanese pilots flew into combat knowing they were riding paper dragons, that survival depended entirely on not being hit. This was acceptable within the framework of Bushido tradition, which valued offensive spirit over defensive preparation. The pilot was expected to destroy his enemy before sustaining damage himself. Death in combat was not a failure to be engineered away, but an honorable conclusion to be embraced. American pilots, trained in a culture that valued the individual life, and equipped by a nation with resources to spare, approached the problem differently. When reports of the Zero's capabilities reached Washington in early 1942, the response was not despair, but adaptation. American factories didn't try to build a better Zero. They built something entirely different, aircraft designed around pilot survival, mechanical reliability, and most importantly, mass production. The P-51 Mustang that emerged from North American Aviation's factories in 1943 couldn't outturn a Zero in a dogfight. It didn't need to. The Mustang was faster, more rugged, and packed sufficient firepower to shred a Zero in a single firing pass. Its armored cockpit, self-sealing fuel tanks, and robust airframe could absorb punishment that would have obliterated a Japanese fighter. And while Mitsubishi was celebrating the completion of its 5,000 Zero, North American Aviation was producing Mustangs at a rate that would ultimately exceed 15,000 aircraft, and that was just one fighter type from one manufacturer. The Japanese engineers who designed the Zero were not inferior to their American counterparts. In many ways, they were more innovative, more daring in their willingness to push the boundaries of what was technically possible. But they were operating within constraints that no amount of engineering brilliance could overcome. Japan's industrial base in 1941 produced approximately 5 million tons of steel annually. The United States produced 75 million tons. Japan's oil reserves, even including the resources of conquered territories in the Dutch East Indies, amounted to a fraction of American petroleum production. When Japanese planners calculated their war production goals, they worked backward from scarcity, asking, how can we build the maximum combat capability from limited resources? American planners worked forward from abundance, asking, how can we most efficiently convert our industrial surplus into military hardware? The answer to the American question was standardization, mechanization, and scale. At the Consolidated Aircraft Plant in San Diego, engineers designed the B-24 Liberator with mass production as a primary consideration. The aircraft's components were broken down into sub-assemblies that could be manufactured at multiple locations, then shipped to final assembly plants for integration. Ford's Willow Run facility employed 42,000 workers at its peak, operating around the clock in 3 shifts. The assembly line moved continuously. Workers didn't move to the aircraft moved to the workers, each station performing specialized tasks in perfect sequence. This was industrial warfare as symphony, each instrument playing its part in a composition that valued quantity and consistency over individual craftsmanship. By contrast, Japanese aircraft production remained rooted in traditional manufacturing methods. Skilled craftsmen hand-fitted many components. Quality control meant inspection and refinement rather than standardized tolerances that eliminated the need for fitting. When American bombers damaged a Japanese aircraft factory, reconstruction often required months because the workforce's accumulated expertise was difficult to reconstitute. When German U-boats or American submarines sank a Japanese freighter carrying aircraft components, those components couldn't be easily replaced from alternative suppliers because each factory maintained slightly different specifications. The Japanese production system was artisanal in an age that demanded industrial standardization. The men who built Zeros in the Nakajima and Mitsubishi factories took immense pride in their work. Many had been recruited from the finest technical schools in Japan, trained in traditions that valued precision and dedication to craft. They worked 12-hour shifts 6 days a week for wages that purchased barely enough rice and fish to sustain their families. They did this willingly, understanding their labor as service to the nation and the emperor. When a completed Zero lifted off on its maiden flight, factory workers lined the airfield perimeter, waving as the aircraft climbed into the sky. That Zero represented thousands of hours of human effort, the collective will of a nation straining every sinew toward victory. It was personal. It was sacred. The workers at Willow Run viewed their labor through a different lens entirely. They were producing bombers, certainly, but they were also earning $1.25 per hour, premium wages in Depression-era America. They belonged to the United Auto Workers Union, which negotiated for benefits, safety conditions, and grievance procedures. The factory cafeteria served hot meals subsidized by Ford. On-site medical facilities treated injuries and illness. Company-sponsored childcare centers allowed women to work the assembly lines while their children were supervised by trained staff. This was industrial mobilization conceived as social contract. The government and corporations asked for labor, and workers received in return not appeals to patriotic sacrifice, but tangible improvements in material welfare. The B-24 bombers that rolled off the line every 63 minutes were products of this bargain, built not by workers who saw themselves as servants of a divine emperor, but by citizens who understood their labor as contribution to a democracy that guaranteed them rights, wages, and a future beyond the war. By 1943, the arithmetic of production had become undeniable. Japan's aircraft industry, operating at maximum capacity, produced approximately 16,000 military aircraft that year across all types: fighters, bombers, reconnaissance planes, trainers. The United States produced 85,000 military aircraft in the same period. This was not a gap, it was an abyss. For every zero that lifted off from a Japanese carrier deck, 4 or 5 American fighters and bombers were entering service. But the disparity extended beyond mere numbers. American aircraft were improving with each production run, incorporating lessons learned in combat, upgraded engines, better weapon systems, enhanced avionics. Japanese aircraft were frozen in their designs by the limitations of production capacity. Introducing a new aircraft type meant retooling factories that were already struggling to meet demand with existing designs. So the Zero continued rolling off assembly lines in 1944, essentially unchanged from its 1940 configuration, facing American fighters that had evolved 3 generations beyond it. Japanese pilots began to understand the scope of their industrial disadvantage long before their commanders acknowledged it. In the skies over Guadalcanal in late 1942, Zero pilots, who had dominated the war's opening months, found themselves confronting increasing numbers of American aircraft. They still won dogfights, still achieved favorable kill ratios, but they were fighting 3, 4, 5 times each day, while new American pilots arrived in seemingly endless succession. A Japanese naval aviator who survived 6 months of combat was considered a veteran. An American pilot who survived 6 months was still halfway through his standard combat tour. The Americans could afford to lose pilots and aircraft in the learning process. Japan could not. Every Zero lost represented not just the aircraft, but the irreplaceable pilot, a man whose training had consumed 3 years and resources the nation could not spare to duplicate. Lieutenant Saburo Sakai, Japan's third-ranking fighter ace who survived the war with 64 confirmed kills, wrote in his memoir of the growing realization that his nation was being overwhelmed. "We believed our spirit was stronger," he recalled. "We believed our training was superior. We believed our aircraft in the hands of warriors dedicated to the emperor would prevail. But we did not believe America could produce aircraft the way they produced automobiles. We thought their industrial strength was propaganda. We were wrong." Sakai's account captures the profound psychological shock experienced by Japanese military personnel as they confronted American material abundance. It wasn't that American pilots were better. Early in the war, they decidedly were not. It wasn't that American aircraft were superior. The early Wildcats and Warhawks were inferior to the Zero in most performance metrics. It was that America simply built so many aircraft, trained so many pilots, produced so much fuel, ammunition, and spare parts that individual superiority became strategically irrelevant. The symbolic power of industrial abundance extended beyond aircraft production into every dimension of military logistics. Japanese soldiers who captured American supply dumps in the Philippines and Dutch East Indies found themselves confronting stores of material that defied their understanding of warfare. Warehouses filled with spare parts, tools, and equipment testified to a military doctrine built on redundancy and surplus. American ration containers held not just food, but cigarettes, candy, coffee, and other luxuries. Medical supplies existed in quantities sufficient to treat not just urgent battlefield injuries, but routine illnesses. To soldiers of an army that frequently operated on starvation rations and improvised medical care, these discoveries were simultaneously encouraging, proof that America was soft, unwilling to sacrifice, and terrifying, evidence that America possessed resources so vast it could afford to be wasteful. The can of Spam became, in the memories of Pacific War veterans on both sides, a symbol of this disparity. American forces consumed enormous quantities of canned meat, a processed pork product that was nutritionally adequate if culinarily uninspiring. Soldiers complained endlessly about Spam, developing dozens of derogatory nicknames for the ubiquitous ration component. But they were eating protein with every meal, maintaining strength and health even in the most remote combat zones. Japanese soldiers, meanwhile, often subsisted on rice mixed with whatever could be foraged locally. On islands cut off from resupply by American submarines and aircraft, Japanese garrisons faced slow starvation. They ate grass, tree bark, and when those were exhausted, the leather of their boots. American soldiers grumbled about Spam while opening their third can of the day. The final accounting of aircraft production tells a story more decisive than any battle. Japan produced approximately 76,000 military aircraft between 1941 and 1945 across all types. The United States produced 300,000. This 4-to-1 ratio understates the actual disparity because it doesn't account for aircraft quality, pilot training, logistic support, or operational sustainability. A Japanese aircraft entering service in 1945 did so in an environment where fuel was scarce, spare parts non-existent, and experienced maintenance personnel depleted by death and conscription. An American aircraft entering service did so as part of a logistics system that provided everything from engine overhauls to replacement propellers with assembly line efficiency. The effective disparity was not 4-to-1 but something closer to 10-to-1 when accounting for operational sustainability. The workers at Willow Run who had built B-24 Liberators every 63 minutes at peak production learned of Japan's surrender on August 15, 1945 during the second shift. The assembly line stopped. For the first time since 1942, the factory fell silent. Workers gathered around radios in the cafeteria, listening to reports from Tokyo. Some wept. Others cheered. Most simply felt relief that the machinery of war could finally cease its relentless operation. The last B-24 produced at Willow Run, number 8685, sat incomplete on the assembly line. It was never finished. Within months, the plant began conversion back to automobile production. The workers who had built bombers returned to building cars, collecting their union wages. 6,000 miles west, in the ruins of Nagoya, workers at the Mitsubishi aircraft plant surveyed the wreckage of their factory. American firebombing had destroyed the assembly halls, melted the machine tools, and scattered debris across acres of scorched earth. Somewhere in the rubble lay the jigs and fixtures that had shaped Zero fighters. The workers, many suffering from malnutrition and injuries sustained during the raids, began the labor of clearing debris by hand. They had no machinery for reconstruction, no immediate prospects for employment, no certainty about where their next meal would come from. The factory that had produced some of Japan's 10,000 Zero fighters would never build another aircraft. Within a decade, Mitsubishi would shift to producing automobiles, competing in global markets with the same Ford Motor Company that had built Liberators at Willow Run. But in August 1945, standing in the ashes of their workplace, those workers could only contemplate the vast distance between the pride they had felt when a 5,000 Zero rolled off the line and the devastation that now surrounded them. The fundamental lesson of the Pacific Air War was not about courage, skill, or technological innovation. Both sides possessed these qualities in abundance. Japanese pilots were among the most skilled aviators in the world. Japanese engineers produced innovative designs that pushed the boundaries of aeronautical possibility. Japanese workers labored with dedication that bordered on the supernatural, accepting privation and sacrifice that few societies could have sustained. But none of this could overcome the industrial arithmetic that favored their enemy. America did not win the air war by building better fighters, though eventually it did. America won by building more fighters, more bombers, more of everything, at a pace Japan could not match and sustained by resources Japan could not access. The Zero fighter that Japanese engineers built with such care and skill was, in isolation, a triumph of aviation design. But modern industrial warfare does not occur in isolation. It occurs in the context of production capacity, resource availability, logistics networks, and ultimately, the fundamental question of whether a nation's industrial base can sustain the consumption of material that modern combat demands. Japan entered the war with a brilliant military machine built on a fragile industrial foundation. America entered the war with a massive industrial machine that could produce military capability almost as an afterthought. In the decades after the war, historians would debate the wisdom of Japanese strategy, the morality of American tactics, the individual decisions that shaped the conflict's course. But beneath all these questions lay the simple, brutal mathematics of industrial production. 10,000 Zero fighters against 100,000 Mustangs and Liberators. Skilled craftsmen working 12-hour shifts against mechanized assembly lines operating around the clock. A nation mobilized for spiritual war against a nation mobilized for industrial production. The result was written in the factories before the first shot was fired, recorded in production schedules and shipping manifests, calculated in steel tonnage and man-hours long before it was confirmed in battle damage reports and casualty lists. The war did not end because Japanese soldiers lost their fighting spirit. It ended because there were no more aircraft to fly, no more fuel to power them, no more factories to build replacements. The machinery of war that had begun with such confidence, with engineers bowing to the 5,000, ground to a halt not in a single catastrophic defeat, but in the slow exhaustion of resources that could never be replenished. American bombers continued flying, American factories continued producing, American workers continued collecting their paychecks, all sustained by an industrial system so vast and robust that war production barely strained its capacity. The symbolic power of this disparity outlasted the war itself. In the Reconstruction era, when Japanese engineers worked alongside American advisors to rebuild their shattered industries, they studied the methods that had produced such overwhelming material superiority. They learned about standardization, mass production, statistical quality control, and logistics management. They applied these lessons to peaceful production, building the industrial miracle that would transform Japan into the world's second-largest economy by the 1980s. The spiritual dedication that had once produced handcrafted Zero fighters was redirected toward producing automobiles, electronics, and precision machinery using the mass production techniques they had once fought against. But in the summer of 1945, as workers cleared debris from bombed factories and farmers returned to fields scarred by war, the lesson was simpler and more immediate. Spirit, courage, and skill are necessary for warfare, but they are not sufficient. In the end, industrial capacity determines outcomes. The nation that can produce more, transport more, replace losses faster, and sustain its forces through superior logistics will prevail regardless of the individual quality of its weapons or the dedication of its soldiers. Japan built 10,000 Zero fighters with reverence and pride. America built 100,000 Mustangs and Liberators with assembly line efficiency. The factories fell silent. The assembly lines stopped. The workers went home. And in that silence, in that cessation of the great industrial symphony that had sustained for years of global warfare, lay the final truth. Modern war is not won by the best weapons, but by the most weapons. Not by the finest pilots, but by sufficient pilots. Not by the greatest sacrifice, but by sustainable production. The Zero fighter was a masterpiece. The Mustang and Liberator were products. In the arithmetic of total war, products defeated masterpieces every time.